First, I'll be going through how to draw a polygon using Vulkan on Android. So we'll be drawing a polygon which is a six-sided polygon. So that's a hexagon. I first did this. I first did it on the desktop. So maybe I can run that and then ported it to Android. So maybe I can run that first just to see what we'll be drawing, and then I'll go through the how to do this on Android. So I'll just run this on the desktop first, the desktop code. So we are drawing a hexagon with some given coordinates. Okay, so let's go and look at how to do this on Android. The main difference between doing it on the desktop and Android is mainly on how you handle the window aspect, the resizing of the window, the setting up of the surface, and all that. Yeah, but most of the other principles, as we shall see, remain the same. So most of the code, the functions, are in this header file, and the entry to the main the CPP file contains the main entry into the application. This is basically what sets up the application, and then we are able to. So when the Android native window starts, we are able to get into the Vulkan, the backend now, through by calling the init Vulkan. So let's just go straight to that function. I'll just jump to it. Yeah. So what it takes to draw the polygon is basically a series of functions or procedures that we have to follow to be able to draw that Vulkan on the screen, to be able to render it. So the first thing we do is to create the instance. So I just be going through the functions, the important functions, looking at each of them. Yeah, and so Vulkan application starts by setting up the VK instance. So let's jump to that function and look at it. Yeah, so we create the VK instance. We set up some things here, describing our application and any extensions that we'll be using. Yeah, maybe like validation layers for debugging and all that. And then after creating the instance, let's just go back here to the next step. After creating the instance, the next thing that we need to do is create the surface that will be able to, where we can be able to to display the window, setting up the window now on Android. And this is where the difference comes in between Android and desktop, how you set up the window and everything. And then we also need to check if the device is suitable. So here below here are a series of functions to find if the physical device is suitable to execute Vulkan commands. Yeah. So this is basically a series of functions to help us to select the physical device. Yeah. So you can query for properties like device capabilities, and select the correct, check if the device supports what the capabilities that we need it to, and the extensions that we need. Yeah. So these are the functions to help us do that. Is the function to check if the device requires, for example, the device extensions that are supported. Okay, coming back to our list of functions. The other thing that we need to do is create, after now picking the physical device, we create the logical device and queue families. So this is the function that does that. We find the queue family supported by the physical device, and then we create the device queue for the unique families. Yeah. So here we describe more specifically which device features we'll be using. Queues are allocated from queue families, where each queue family supports a specific set of operations in its queues. Yeah. So here we specify the device features, and then we create the logical device here. Create the logical device there. And then the next step now is to create, the window surface and the swap chain. After creating the logical device, we need to do now things to create to do we need to do things now to do with the window, the swap chain. And we need two components to actually render to a window. So basically we're looking at the surface format here and the swap chain. I think those are the most important. So things to do, like the presentation mode. Okay, on Android we straight away just select this particular presentation mode. On the desktop we would usually pick from several presentation modes, pick the best one, but on Android this is always supported. So we just the FIFO is always supported, so we just pick that one. We know that will work on Android, on an Android phone. Yeah. Basically the swap chain is a collection of render targets. So then the next thing is to draw an image. Okay, we need to draw an image now acquired from the swap chain, and we have to wrap it to our image view. So then the next step will be now to create the image views. Basically an image view references a specific part of an image that is to be used. Yeah. And then from there now we create the render pass. Basically in Vulkan, what a render pass does is that it describes the type of images that are used during rendering operations, and also how they'll be used and how their contents should be treated. We could also specify like a subpass, any dependencies for the subpass. In our case here we are using only just one subpass. We are specifying one subpass. Yeah, and then we create now the render pass here. And what vkcheck does is basically vkcheck, what it does is it runs the commands that we give it. You'll notice that we'll be using vkcheck whenever we are creating components. It tries to create whatever we are creating and returns a runtime error if the creation fails. Yeah, then from there now we come to one of the most important parts in Vulkan, which is now the graphics pipeline. So we set it up by creating a graphics pipeline object, but first we need to define the shader modules, which is where now we define the vertices, the colors, and our shaders are here in this folder. Yeah. So here we have the vertex shader file here and the fragment shader here. So in my case I'm not coding the coordinates here. So we'll be passing them using a vertex buffer to the shader file, and then the shader passes them to passes the vertices and the color to the shader fragment, which now will then pass it to a pipeline to render it. So coming back here, in our graphics pipeline, we get the compiled shader and fragment files. We load them so that now we can be able to draw the vertices and the colors, specify the viewport state, rasterization here, a lot of configurations that we need to do here that Vulkan enables us to do, like specifying the multi-sample state and the color blending state. There's no default color blending state in Vulkan. We can just play around with it. That's the good thing about Vulkan. It gives you all that flexibility. Yeah. And then finally we can now create our graphics pipeline and clean up the shader modules. Yeah, so these are helper function, of course, to help us to create the shader modules, which we are reading from the binary files, which that is the compiled shader files. Yeah. So after creating our pipeline, the other important thing now is to create the command pools and the command buffers. Yeah, so okay, many of the operations in Vulkan that you want to do, like the drawing, need to be submitted to a queue, but they first need to be recorded in a command buffer. They first need to be recorded in a command buffer before they can be submitted, and then these command buffers are allocated from a command pool now. Yeah, so to draw now our polygon, we need to record the command buffer. We need to record the command buffer, which is here. Create it and also record. Let me just go to that code. Record command buffer. Yeah. So we begin, and then we go through a series of setting the viewport, the color, the background color here, which is the clear color, the render pass, and then we bind the vertex. I said we are using the vertex buffer to do that. Okay, so we are using the vertex buffer to pass our vertices to the shader. So let's look at the vertices now, which is what determines how our figure will appear. Okay, so basically our pipeline, our graphics pipeline here, we have configured it to draw triangles, and as we know, an hexagon is made up of 6 triangles. So what we'll be doing is we'll be drawing 6 triangles, and that will make up the hexagon. So we'll just be starting from the center each triangle. From the center point of the given coordinate is 5, 8. Of course, we are scaling it by dividing by 20 to fit to the Vulkan coordinate system, which usually has a range of 1. Yeah. So we draw the first triangle, counterclockwise, go to the next triangle, like that, starting from the center vertex and then following in the previous vertex. You have to follow that order, otherwise the polygon will not be shown. Yeah, so basically I think that's how we draw the polygon. Now I'll be able to run, I'll run this on my Android phone so that we can see how that comes up. Yeah, so I'm launching it on my Vivo phone. I'll just put up the screenshot over here. Yeah, so the reason why it appears down here is because of the coordinate system of Vulkan, which usually has the origin at the top, instead of the bottom side that we are used to. Yeah, so that's it.